Waves. Usually when you think of the word wave, you think of water flowing in at the beach, like this image. However, there's radio waves and microwaves and even ultraviolet waves. So what do they all have in common? Well, waves are repeating disturbances or movements that transfer energy through matter or space. Ocean waves disturb the water and transfer energy through it. Light is a type of wave that can travel through empty space to transfer energy from one place to another, such as from the sun to the earth. Picture yourself sitting in a boat on the ocean. Approaching waves will rock your boat, but they don't bring your boat closer to shore. This is because even though the boat is moving up and down, waves don't carry the water along with it. Waves only carry energy, and that energy is what moves towards the shore. So the boat will stay in the same place. All waves have this property. They carry energy without transporting matter from place to place. If you were to drop a pebble into the middle of a puddle, that pebble causes a disturbance that moves outward in the form of a wave. When you drop that pebble, it was moving down through gravity, and that energy from the moving pebble transferred some of its energy to the nearby water molecules, causing those molecules to move, bumping into the next molecules, which of course then bumps into their neighbor watering molecules, and it will keep going with the energy moving further and further away from the source of the disturbance. Waves will continue to travel as long as there's energy to carry it. Anything that moves up and down or back to forth in a rhythmic way is vibrating, and all waves are produced by something that is vibrating. Going back to the ocean waves move through water to reach the shore. If you heard a siren go off, that they create sound waves, those sound waves also travel through the air to reach your ears. In both cases, the matter that the waves travel through is called a medium. Mediums can be a solid, a liquid, or a gas, and even a combination of these. So for the sound wave, or that siren, the medium was air. For the ocean wave, the medium was, that's right, water. However, not all waves need a medium. Some waves, such as light and radio waves, can travel through space. Waves that can only travel through matter are called mechanical waves. There are two types of mechanical waves, transverse waves and compressional waves. In a transverse wave, matter in the medium moves back and forth at right angles to the direction that the wave travels. For example, if you hold one end of the rope while your friend holds the other end and you start shaking your end of the rope, you will send waves down to your friend's hand. You are making what are called transverse waves like those found in the ocean. The wave and its energy travel from you to your friend as the rope moves up and down. In compressional waves, matter in the medium moves back and forth along the same direction that waves travel. A way you can model a compressional wave is to hold a slinky and stretch it out. If you hold one end and your friend holds the other end of the slinky and you push your energy toward your friend's hand, a wave will travel along the spring and it will look as if the whole spring is moving toward one end. An example of compressional waves are sound waves. When a noise is made, for example, someone banging on a drum, nearby air molecules are pushed together by those vibrations, and the air molecules are squeezed together like the coils in the slinky toy. In the compressions, they travel through the air to make a wave. Okay, it's time to show what you know.